All right, if we take a look at this first problem, okay, when you look at the two numbers, can you express both sides of this equation with the same base? Yes, and the base is 5. So if we look at the left side, it stays a base 5. Nothing changes. But on the right side, if we move this 5 up from the denominator into the numerator, we have to change its power to what? A negative, so it becomes a negative 1. And so here we can equate our powers. 1 minus 2x has to equal negative 1. Solve for our x. So if we subtract a 1 from both sides, get negative 2x is equal to negative 2. Divide both sides by negative 2. We get x is equal to 1. So let's confirm this. Again, make sure that this is true. 2 times 1 is 2. 1 minus 2 is negative 1 is 5 to the minus 1 equal to 1 over 5. Yeah, so that checks. All right, let's go to B. Okay, so on B, we have, or what base will we have to assign to in order for both these sides of the equation to have the same base? 3. So the left one stays as it is. Okay, now notice this isn't a power to a power. Okay, this isn't 3 to the power of x all cubed. Okay, this is 3 to the power of x cubed. So the whole x cubed is the power. Okay, and then here the 9 can be changed to a base 3, 3 squared to the power of x. Now, do you guys see the difference in how these are written? This one now is a power to a power. So as we continue to rewrite this, 3 to the power of x cubed is equal to, when you take a power to a power, you multiply. Okay, so now when we equate these, and this is where we haven't specifically talked about this yet this year, but hopefully you remember how to work with different types of equations. I see some head shaking, and we'll talk about it. But when you equate these, x cubed is equal to 2x. Here's our equation. Right, anytime you're dealing with an equation and there's more than one variable term, move all the variables to one side. So in this case, if we subtract a 2x to move everything to one side, and we're going to compare it to 0, because that's the only thing that we have. It's called the zero product rule, right? Is if we turn something into a product or a group of factors set equal to 0, then you can take each of the individual factors, solve for what would make it 0, and that's your solutions. You guys vaguely recall doing that. Okay, so what common factor can we remove from these two terms? Take out an x, leaving an x squared minus 2. Each of those is equal to 0. So when we solve for this, take each of these factors, apply the zero product rule, and solve. So we get x is equal to 0. Here's one possibility. And the other possibility, x squared minus 2 is equal to 0. So if we solve for the x, in this case now, it's a higher power than 1, but there's only one x term. So if you only have one x term in an equation, isolate your x. So here we can move the 2 over. We add 2 to both sides. Okay, and then the way that you would do this is you do what's called extract the square root. And you take the square root of both sides. Whenever you take the square root of an x squared, you have to account for both its positive and negative root. So here we have plus or minus root 2 would be the other possibility. Okay, so our solution here is negative square root 2, 0, and 2. Anytime you have multiple answers, again, as you enter them, please write them in order from the lowest number to the greatest number, please. All right, let's take a look at sample C. Okay, so now we have some combining to do here, right? In order to multiply numbers, or in order to multiply exponents, you have to, again, have them in like bases. Okay, so is there a way that we can write 2 and 8 as the same base? Okay, good. So use a base of 2. So we have 2 to the x times 2 cubed to the negative x. And that's all equal to, and we might as well go here. Can we express 4 in base 2 as well? 2 squared. All right, so as we work through this problem, we have now power to a power. So when we take a power to a power, we multiply power. So we get minus 3x. Same thing here. Take a power to a power, you you multiply. You get a 2x. And now here, when you are multiplying two exponents with the same base, what do you do with their powers? Now you add them. So x plus a negative 3x. And so when you combine these all, x minus 3x gives you negative 2x. And so our final step here is to equate our powers. So negative 2x has to equal 2x. And now we solve. Okay, so what do we do in this problem? You combine like terms? Yeah, they're like terms, right? So let's add 2x to both sides. We get 0 is equal to 4x. Divide by 4. You want to go through all the steps involved. And so what do we get for our value of x? 0. Let's check it and make sure that works. Is it true that 2 to the 0 times 8 to the negative 0 is equal to 4 to the 0? And what is anything to the 0 power? Any non-zero base is 1. So is it true that 1 times 1 over 1 is equal to 1? Yeah, it checks. So your answer is 0. All right, the final one, and the one that is maybe confusing because it involves an e. Okay, we do the same thing. Do we have all of these exponents in terms of the same base? Yeah, it's just that natural base e, right? So let's go ahead and apply all the properties of powers or exponents to these. When you take a power to a power, you do what? You multiply. So e to the 4x times here e to the x squared. Again, this is not a case of a power to a power. It's the power of x squared. E to the 12. Okay, so we have the left side still has a product of exponents with the same base. So what are we going to do with their powers? When you multiply two exponents with the same base, you add their powers. So we're going to add x squared to 4x. And so what we're able to do here is we're able to express both sides in terms of the same base. So we can now equate their powers. So 4x plus x squared is equivalent to 12. And so now we have what's called a quadratic equation, right? We have a power of 2. Is there just a single variable term or multiple variable terms? There's multiple, right? Even though they're all base x's, we have an x squared, a second degree term, and a first degree variable term. So anytime you have more than one variable term, move everything to one side. And so I'm going to reorder this in standard form. So x squared plus 4x, subtract the 12 from both sides, and that's equal to 0. And now, again, applying the zero product rule, if we can factor this left side, set each of the factors equal to 0, and solve, we have our answer. Okay, so let's do that. Can you factor this expression? Yeah, what two factors of negative 12 have a sum of positive 4? Positive 6, negative 2. So we set each of these equal to 0. Okay, and again, if you're familiar with this, you don't have to actually write this step. You can probably mentally solve it. What value of x would give you a 0 in this factor? What value of x would give you a 0 in this factor? If you're actually putting it through the whole process, you get x is negative 6, x is positive 2. Okay, and let's test these, make sure they work. Okay, so when we plug this back in, okay, 4 times a negative 6 is negative 24. Negative 6 squared is 36. Is negative 24 plus 36 equal to 12? Yeah, so that one checks. What about 2? 4 times 2 is 8 plus 2 squared is 4. Is 8 plus 4 equal to 12? Yeah, so that checks as well. So you have those two solutions.